In this section of notes, we're going to expand what we know about disjoint or mutually exclusive events and look at what happens when there is an overlap between two events. So we're looking at this example where we have a certain number of people and then we've broken them up into categories, whether or not they have pierced ears and whether or not they are male or female. So first we have just definitions of event A being male and event B being someone that has pierced ears. So every student is equally likely to be chosen. So there's 103 students that have pierced ears. So the probability of someone having pierced ears, or the probability of event B occurring, would be 103 out of 178. So then we want to find the probability that someone is male and has pierced ears. That's only these 19 people here that are in the intersection of the row for male and the column for pierced ears. So the chances of someone being a male and having pierced ears is 19 out of 78. But here's where things get a little tricky for part C, where we want to find the probability that someone is male or has pierced ears. We have to be careful that we don't count anyone twice. So there are 103 people we saw from part A that have pierced ears, and when we did part B, there were 90 people that were male, but we wanted to be careful about not counting the 19 people that were both male and have pierced ears. We don't want to count them twice. So we want to be careful here. So this is an example of a probability question where the two events are not mutually exclusive. They're not disjoint. In other words, they are overlapping. So in our last section of notes, we had an addition rule where we just took two events and added their probabilities, but we mentioned that that only works when they're mutually exclusive or when the two events don't have any overlap. When our events have overlap, we have to adjust our formula a little bit. So now this formula shows us subtracting out the overlap piece. So if you counted the males with pierced ears twice, you'd have to subtract them out once so that you're not counting anyone twice. That's basically where this general rule for addition of two events is coming from. Now, if the two events are actually disjoint or mutually exclusive, then the probability of them both happening simultaneously is 0. So subtracting 0 leaves you with that original addition rule. So this rule here will work in any situation. Now you might recognize some of the notation or the Venn diagrams, or this may be new to you, so we'll take a look at some of the things that we have seen in the past. So one notation we talked about the other day is complements. Remember, we also mentioned that instead of the little c that looks kind of like an exponent, sometimes you'll see something that we call a prime, which looks sort of like an apostrophe, like if you said that something belongs to someone and you have an apostrophe s, it looks sort of like an apostrophe up there instead of a c, so that would be equivalent. So if circle A is an event happening, then everything outside of the circle would represent it not happening, so that would represent the complement. If two events are mutually exclusive or disjoint, that means they have nothing in common, so the two circles don't overlap this time. Remember, the S is your sample space. So that's what we were working with prior, but here's where we are today. Now we've got an overlap. So the overlap piece, the part that's shaded green here, that is our intersection. That's where we said and. So in that last problem, the green part would represent the males who had pierced ears. And then you'll see that notation. It looks kind of like an upside down U. That notation means and or intersection. Now if I want to do an or problem, so everything in group A or group B, including both, we would have this shaded green section, and we use a union symbol, which looks essentially like a U without any overlap there. Last, we want to make a few connections between the two-way table and the Venn diagram. So you'll notice that the numbers here within the table are the same numbers that show up over here as the entries in the Venn diagram, and that will always be the case. So like these 19 people are the people that are both male and have pierced ears. So that shows up in the overlap because the green part represents both male and having pierced ears. Whereas the 71 represents people that are male, but they don't have pierced ears. So this 71 is only this yellow like Pac-Man piece. The people that are male, but they don't have pierced ears. So they have to be outside of the blue circle since they don't have pierced ears. And again, just remember these notations down here. And we use this intersection for, looks kind of like an upside down U or maybe like a lowercase n without the little line. And if we had an or, that's the one that looks like this, the union symbol.